Hello all, so let us look at few more problems in today's class. So let A, B and C be finite sets. Then we need to show that cardinality of A complement intersection B complement intersection C is equal to cardinality of C minus cardinality of A intersection C minus B intersection C plus A intersection B intersection C. So let us see the proof for this. So we need to show that cardinality of A intersection A complement intersection B complement intersection C is equal to this sum. Okay, now if you have A complement intersection B complement, so by De Morgan's law that can be written as A union B whole complement, so that is C intersection A union B complement. Now we have seen this property in the last class. So cardinality of A complement intersection B is equal to cardinality of B minus A intersection cardinality of A intersection B. So this will be equal to cardinality of C minus cardinality of A union B intersection C where. Okay, so that will be equal to cardinality of C minus, now this can be written as cardinality of A union C, sorry, A intersection C union B intersection C. And now by so this is in the form cardinality of A union B. Now that is equal to cardinality of A intersection C plus cardinality of B intersection C minus cardinality of A intersection C intersection B intersection C. So that will be equal to cardinality of C minus the cardinality of A intersection C minus B intersection C. Now this will be plus. Now all are intersections, so you can combine them. So that is A intersection B intersection C. So that gives the required result. So cardinality of A complement intersection B complement intersection C is equal to cardinality of C minus A intersection C minus cardinality of B intersection C plus A intersection B intersection C. So that is the proof. Now let us see a problem using that result. So find the number of integers in the set S equal to, so you have the set 1, 2, 3 etc. up to 10 raised to 3 which are not divisible by 5 nor by 7 but are divisible by 3. So again നമ്മൾ ഇന്നലെ കണ്ട problem പോലെ, so let us define bk to be the set of all x belongs to S such that x is divisible by k. And now we need to find the cardinality of the set which is not divisible by 5 nor by 7 but are divisible by 3. അപ്പോൾ നമുക്ക് വേണ്ട സെറ്റ്സ് ഇവിടെ B3, B5, B7 ആണ്. So we need to find cardinality of, it must be not divisible by 5. അപ്പോൾ B5 complement വരും. So B5 complement intersection B7 complement intersection B3. So it is in the form of the property we have seen now, A complement intersection, B complement intersection, C. So that will be equal to cardinality of B3 minus cardinality of B5 intersection B3 minus B7 intersection B3 plus B5 intersection B7 intersection B3. So now this will be equal to, cardinality of B3 will be, so that is integer function, so 1000 by 3 varum minus B5 intersection B3 will be 1000 by 15 varum, so minus 1000 by 21 plus 1000 by, so this is B3, so you will have 35 into 3. So this is the required value. So let us find the corresponding values. So you will get are going to be the values. So the corresponding integer part is 333 minus 66 minus 47 plus 9. So we'll get the value to be 229. So that is the required number of integers. Let us move on to the generalized principle of inclusion and exclusion. And now for stating the generalized principle of inclusion and exclusion, we need to understand a few more definitions. So we'll see those first. Okay. So let me take S to be a given universal set. So let S be a given universal set. And let me take A to be a subset of S. Now I'll define something called a property on S. So I will say that ഇപ്പോൾ നമുക്കൊരു യൂണിവേഴ്സൽ സെറ്റ് തന്നിട്ടുണ്ട്. അപ്പോൾ യൂണിവേഴ്സൽ സെറ്റിൻ്റെ കുറേ സബ്സെറ്റ്സ് എന്ന് പറയുന്നതാണ് A. Let me define a property P. അപ്പോൾ ഞാൻ പറയുന്ന ഇതാണ്. അപ്പോൾ X will possess the property P if X belongs to A. അപ്പോൾ നമ്മൾ എടുത്ത സബ്സെറ്റിലാണ് X എങ്കിൽ, so if X is belonging to my subset A, I will say that X possesses the property P. Okay. അപ്പോൾ any property P will give us a subset of A. അപ്പോൾ ഇന്ന പ്രോപ്പർട്ടി സാറ്റിസ്ഫൈ ചെയ്യുന്ന എലമെന്റ്സ് എന്ന് പറയുമ്പോൾ നമുക്ക് അതിന് കറസ്പോണ്ടിങ് ആയിട്ട് നമ്മുടെ സബ്സെറ്റ് A കിട്ടും. സോ I can define different properties on a given set A. So that is the meaning of the property. Okay. So then any subset A of S induces a property P such that for any X belongs to S, so X possesses the property P if and only if X belongs to A. So this is how we define the property. So an element X possesses a property P if and only if X belongs to the set A. So therefore any property P of elements of S determines a subset A of S such that elements of A are precisely those possessing the property P. So any property P, that property will give a subset A. A elements that will be the elements of S which possesses the property P. And now let me define different properties on the set S. So let S be, so let me take the universal set to contain n elements. So let S be an n element universal set, and let P1, P2, etc. PQ be Q properties for the elements of X, for the elements of S, where Q greater than or equal to 1. ഇനി നമ്മളൊരു property എടുക്കുമ്പോൾ the property may be possessed by no element, കാരണം നമുക്ക് empty set subset ആണ് അതിന് corresponding ആയിട്ട് property ഉണ്ടാവാം. So properties may not be possessed by any of the elements. It can be possessed by some of the elements, or it can be possessed by all of the elements. So that is the speciality of properties. So a property may be possessed by none, some, or all the elements of S and on the other hand an element of S may have none, some, or all of the properties. അപ്പോൾ നമ്മളൊരു പ്രോപ്പർട്ടി എടുത്തു കഴിഞ്ഞാൽ ആ പ്രോപ്പർട്ടി പൊസസ് ചെയ്യുന്ന 0 എലമെന്റ്സ് ഉണ്ടാവാം, സം എലമെന്റ്സ് ഉണ്ടാവാം, അല്ലെങ്കിൽ ഓൾ ദി n എലമെന്റ്സ് ക്യാൻ പൊസസ് ദി പ്രോപ്പർട്ടി. ഇനി അതുപോലെ നമ്മൾ സെറ്റിലെ ഒരു എലമെന്റ് എടുത്തു കഴിഞ്ഞാൽ ആ എലമെന്റ് ഒരു പ്രോപ്പർട്ടിയും പൊസസ് ചെയ്യണമെന്ന് നിർബന്ധമില്ല. അതുപോലെ ആ എലമെന്റ് 2-3 പ്രോപ്പർട്ടീസ് പൊസസ് ചെയ്യാം, അല്ലെങ്കിൽ ആ എലമെന്റ് എല്ലാ പ്രോപ്പർട്ടീസും പൊസസ് ചെയ്യുന്ന ഒരു എലമെന്റ് ആവാം. ഓക്കെ, സോ and on the other hand an element of S may have none, some, or all the properties. So that is how we have defined it. So S is an n element universal set and P1